Welcome to the DAK Machine Safety Podcast. We support the development of a safer, sustainable workplace. In this podcast episode, we will discuss Task-Based Risk Assessment, TABRA, which was developed by General Motors and the United Auto Workers to identify routine tool changes and other minor servicing activities that could be performed using control-reliable energy control systems in lieu of lockout.
Has OSHA recognized the use of the methodology?
Yes, the TABRA methodology was recognized in OSHA's December the 16th, 1999, letter to Mr. Tom Weekly, then Assistant Director, UAW General Motors Department. OSHA's letter states, in part, "It is important, as you have stated, to apply this safeguarding technique, MPS, through a hazard analysis process, TABRA, on a case-by-case basis in order to assure that it, in fact, provides effective employee protection."
What is MPS?
GM's control reliable systems were called Monitored Power Systems, or MPS for short. Because of this, they conformed to B11 requirements for control reliability and met OSHA's regulatory requirements.
Did the OSHA letter provide more detail?
Yes, it states, and I quote, "The UAW and GM recognize the importance of designing processes and equipment with effective health and safety controls. Therefore, a pilot program was conducted to determine the effectiveness of employing a monitored power system design approach that removes all hazardous motion energy from devices, equipment, and machinery in a designated area, such as a zone or cell."
How did monitored power control reliable circuits remove the potential for hazardous motion?
The four key elements are: 1. Redundancy, parallel or series; 2. A self-monitoring feature; 3. Fail-to-safe condition with self-testing capability; and 4. Hardware integration, so the MPS may not be bypassed by other control circuitry or hardware. The MPS mode control devices cannot be overridden or bypassed because the authorized person secures his or her plant-approved lock on the MPS gate box before entering the safeguarded area. The gate box serves as a single point of control and accomplishes the same de-energized state as placing individual locks on multiple energy-isolating devices to meet the requirements of 1910-147B and C1.
When and how did the methodology get into ANSI standards?
Mike Douglas, General Motors Manager of Engineering for Safety, and Mike Talbots, GM's Global Regulatory Liaison, brought the experiential knowledge of GM and the UAW to B11 in the late 90s. The B11 efforts led to developing an important B11 technical report published over 2 decades ago.
Tell me more about the technical report.
B11 TR3 2000, Risk Assessment and Risk Reduction. A guide to estimate, evaluate, and reduce risks associated with machine tools, was the seminal work for what came to be known as Task-Based Risk Assessment, TABRA. That technical report became a foundation for B11-0. B11 TR3 adopted the methodology of TABRA, recognized by OSHA, and started on the path of defining acceptable risk.
How is TABRA different than a JSA or hazard analysis?
Task-based risk assessment is a method that asks a worker's subject matter expert to share his or her accumulated experiential learning to walk through every step of a specific task. With the employee who best knows the task, a small team then identifies hazards and assesses risk for each task step.
Please explain more.
TABRA has several differences and advantages compared with a traditional JSA or job safety analysis. Operators, maintenance staff, material handling personnel, and other workers are familiar with and comfortable talking about the details of their work and can walk through each step of what they do for a specific task. TABRA is not only very detailed, but facilitates discussion about variables that might not be present when TABRA is done, but could pose additional hazards. Those variables are then assessed for risk.
How do you assess risk?
First things first. For each task step, hazards are married to that element of the task, creating what is commonly referred to as task hazard pairs. Because some steps have more than one hazard, it is common to find more task hazard pairs than steps of the task.
Can you then assess risk?
Yes, we prefer the simple 4x4 matrix shown in Clause 5 in B11 2023. The left-hand column has probability of occurrence of harm in the heading, with 4 separate rows underneath the heading. 4 terms populate each row: very likely, likely, unlikely, and remote. Now picture 4 columns to the right of the probability column. In the heading, you have 4 categories of severity of harm, including catastrophic, serious, moderate, and minor.
Do you have definitions for each category of probability and severity of harm?
Yes, they are contained in B11 2023. I won't read them here because it would likely be confusing. You really need to look at the matrix to see how the terms come together to identify a level of risk.
How does an individual or team assess risk?
Participants choose the probable occurrence, also referred to as probability. When married with the probable severity of harm, the matrix identifies the risk level as high, medium, low, or negligible. It's important to note that participants may have differences of opinion regarding probability and severity, which obviously affect the estimated level of risk. Capture the different levels of risk to identify the variables of the task.
Why would there be variables in any one task?
Any number of reasons: differences in worker height, strength, variables in products and raw materials, weather, etc. Consider assessing a possible strain for a tall, strong young worker loading and unloading a part. The team may determine that the risk of a strain is negligible to low. However, one of the team mentions that an older person of slight stature had just been hired onto the night shift. The assessment of the risk of a strain for that person might be medium to high. The goal is to find the medium and high-risk situations. You want to capture task variables that may be absent during the assessment. That input will come only in an atmosphere of openness and trust.
I noticed that you don't have a zero risk level.
Correct. Remember that there is no such thing as zero risk. The lowest form of risk in risk assessment is negligible.
I've seen risk assessments using numbers. Is that a more precise methodology?
Risk assessment, whether using qualitative terms like high, medium, low, or negligible, or an assessment using numbers, is still subjective. We prefer the 4x4 matrix described earlier because it is simple and easily understood by workers new to the process. Remember the Deming admonition of drive-out fear. Using numbers or complicated terms or more complicated matrices only adds complexity. Our goal is to make workers comfortable in a process that may well be new to them. In addition, be aware that the safety profession has a reputation among some workers for being overly complex and not understanding the worker's real world.
Why do you keep reinforcing the issue of making the worker comfortable?
We have learned from experience. You want experienced workers to openly discuss the issues they face, particularly the situations where they may have to circumvent safeguarding to do their tasks. They will not do that if they are not comfortable and trust that they will not be admonished for not following policy or procedures.
Whoa. What should I do if a worker admits to defeating a guard or not locking out per our policy?
Listen and seek to understand why they are doing that. Typically, it's not a shortcut, but necessary to perform the task. Safety policies and existing safeguards often force workers to fight the system management believes is there to protect them. If the workers practice malicious compliance and follow the rules, they will likely shut you down. If you want to curtail learning, immediately tell the worker that their actions violate policy. It's a guarantee that they will not tell you what is really happening.
What do I do after the risk assessment?
That is a great question and a very important point for this episode. Let me emphasize that the goal of risk assessment is feasible risk reduction. Do not go out and do 100 risk assessments at one time. The reason for this is simple. Not only is the goal feasible risk reduction, but the time and effort to assess feasibility, control reliability, procure parts for upgrades, plan to install modified circuits or other engineered controls, etc., is a much more difficult and technical process.
But it seems like it would be most efficient to just go out and do as many tabras as possible simultaneously.
Have you heard the expression shooting yourself in the foot? That's what you would be doing. Management and your engineering and maintenance staff have more complex work that requires lead time and money to determine feasible risk reduction. You'd be documenting situations where you have identified risk without risk reduction. That's not a smart thing to do.
But how can I identify potential high risk jobs?
That is an excellent question and relatively simple. Ask your experienced workers, as we noted in the first podcast. To mechanics and experienced operators, ask, if your son, daughter, or family friend came to work here, what job or task would give you the most concern that they might be seriously injured? Make a top 5 or top 10 list, and then go to work on feasible risk reduction. You need to learn the process and make it work in your organization. Trying to eat the elephant at one time will likely result in not achieving your goals. Thanks for tuning in to this episode by DAK Machine Safety. Today we discuss task-based risk assessment. In the following podcast, we'll look at some real-world case studies to understand how the lessons and methods described in this podcast series can lead to operational excellence. You can support us by clicking like and subscribing. Take care, everyone, and until next time.